a lamp just failed in my kitchen. It did that thing where they dip out momentarily and then it just flicks and you're thinking, did that lamp just flick? And then progress over time. There's more flicking until today it just started flicking quite a lot and then just went out and well, it didn't go out completely. It just did that thing where it just glows at a low level. And I thought, well, okay, let's fix it because that'd be quite interesting, particularly as it's a Poundland lamp. But before we go any further with that, I'd like to show you this interesting package that arrived today. So I'm guessing from the fact that this says underwater lights that this device, which I ordered, when did I order this? I'm not sure when I ordered it. But I ordered on eBay. And it says portable boat 12-volt bait waterproof underwater light LED fishing lures lamp. I was more interested in finding out how they've made this waterproof. It looks like a standard sort of lamp housing, but they've kind of sealed the end. They've put a 12-volt lead in it, and I thought that's quite interesting. So I ordered one. I think this is what just arrived with this envelope, which says commercial invoice, 1 times underwater lights. That seems appropriate. So here it is. Oh, that's quite small and light. And inside is a cork. And it says, let's get down on this. Let's get down. It says, hello. We are sorry that there is a quality problem with the item you have bought. We have contacted the supplier to exchange the new item, but it needs around 5 days. So we sent you a gift first. Ooh. Thanks for the cork. Please do not worry about it. We will send correct item to you after we get new item as soon as possible. You can contact us to check the new tracking number if you want to track the second package. There's the clue. If any question, please contact us first. Sorry to bring too many troubles for you. Best regards. Have a nice day. Happy fun face. Right, okay. So, right, I can't really show you this because, well, hold on, I'll just cover my address here. There's the Royal Mail delivery barcode. That means that they have fulfilled the requirement for a trackable barcode, so they can put a link. Oh, did I just go completely off shot with that? I probably didn't. Probably did. I don't know. I'm zoomed in. I'll zoom back out again. We don't need to be zoomed out at the moment. They've fulfilled the requirement to provide a trackable link. They've fulfilled the requirement to post that package with a very light item. The question is my light going to arrive? That's going to be interesting. So my guess is that this is the old Isle of Man shipping thing going on, that because they've either run out of stock or they've found that it costs a bit more to ship to the Isle of Man if they don't use the... Although Royal Mail does ship to the Isle of Man at the same price. My guess is then maybe they've run out of stock and maybe this is a place filler that lets them submit the barcode to eBay and say, we've shipped the item. I'm interested to see what happens. Another thing that arrived today that is much better was this. Oh yes, printed circuit board porn. This is my first ever circuit board from GLC PCB. This is not a promotion for GLC PCB. I paid for these. I just went through the normal channels. In fact, you know what? I ordered, hold on. Let's grab the others here. I ordered the minimum quantity of that size of circuit board, which was 5. And that came to £20 approximately, including shipping, which is exceptional. And this is a controller. It's going to feature in a later video if that whole project comes to fruition, which I think it will. So this is a sort of animation controller for lighting. It's basically speaking, it's got 15 channels that are controlled from a PIC microcontroller. It will be programmed in assembly code and it will basically just sequence the channels according to what we connect this to. But that was fast. And there are a couple of interesting features. I put this order in as a single-sided circuit board, but because most of the circuit boards they deal with are double-sided, they've left the pads off this side, but they have plated through the holes, which that kind of almost disappointing when they do that because it makes it harder for service. The whole reason I went for single-sided is because I was originally going to prototype this myself and then decided let's just go straight to copper and get it manufactured. But Problem with the plated through holes is that if you have to desolder something, it makes that a little bit harder, but you don't have to worry about damaging the plated through hole in this instance because there are only pads on one side. Another thing that's notable is that they always put their number. You can tell them not to put a tracking number on, but they put a number on for the circuit board reference. But in this case, sometimes they print it as an obvious screen print, but they've not done it in this case. In the case of GLC PCB, they've put it in relief on the solder resist side, which means it's completely unobtrusive. It also is very, very detailed, to the point I wondered if they'd just laser scribed that afterwards, but I think it's actually in the screen print, and that is very impressive. So, first circuit boards from GLC PCB, they came through fast, and so far, I am impressed. This is good. Not a paid promotion, not a promotion at all. Well, an accidental promotion because I'm genuinely impressed. Well, there we go. That's good. Back to the lamp. So this, it turns out, is it's labelled electric. It's a 3-watt LED downlight. And it's using the classic YX LED PCB that is used by Poundland. And they currently sell the same model under the Pifco brand. And what's happened here is quite interesting because inevitably, well, can you see the problem already? I shall zoom in progressively until you spot the problem. See the black spot of death? Yeah, okay, it's died a death. It has the black spot of death right here. Let's just draw a sort of little star because it's gone at that point. What's happened here is that this is a capacitive dropper circuit. I can show you the circuit. In fact, I'll just flip this over and show you the circuit. It's the classic capacitive dropper circuit, which has the incoming supply going to capacitor, and the capacitor is what effectively limits the current, because in each half wave of the sine wave, it allows current to shuttle backwards and forwards. But because only a certain amount of charge at that voltage can be held on the plates of the capacitor, only a certain amount of current can move backwards and forwards. That goes through a full bridge rectifier, or as Electroboom would say, a full bridge rectifier with echo added on. That then rectifies that. Other things worth of note, the 1 megohm resistor, it's the classic design. You know, I won't go over this in too much detail. It's so familiar from the dawn of this channel. This is a classic capacitive dropper. The output goes to a capacitor unknown value. I could measure that one at around about 470 nano. This one came about, I would say about 3.3 microfarad, but maybe it's 2.2, maybe it's 4.7, not sure, because there's a 100k resistor across it, and that skews the results when you're measuring through with components in line. There's a 100k resistor across that to make sure the LEDs go out decisively. And also to stop ghosting with capacitive coupling from the mains, because this circuit is the most it's the simplest circuit you could drive LEDs from the mains supply with. I should draw a little sine wave to show this is the mains. Live, neutral, although to be honest it doesn't really matter because this could go in either way round. There's two 100 ohm resistors in parallel, which equates to 50 ohms, and then all the LEDs in series. The LEDs are these special LEDs that have 6 chips. I reckon these are the same ones with 6 chips per package. And there's 10 of them, which gives 60 LEDs in series for the classic 240 volt supply in the UK. Combines to a total of 180 volts, and that just makes it just the most optimal way. Using capacitive droppers are best suited to super long strings of LEDs. You get the cheapy Chinese sellers on eBay that sell a 3-watt lamp, and they have just single LEDs, and they go for a massive dropper capacitor compensate for that. Much higher capacitance, much higher current through the whole circuit. Terrible power factor in this case, because they've gone for this arrangement. Although the power factor of less than 0.5 looks bad, it's actually not too bad in this instance. 2.88 watts, 24 milliamps through those LEDs. Although there's 6 LEDs per package, it's not too bad. That's not really grilling them. And to be honest, these lamps do not run hot. However, it's notable that the failure has occurred in one particular part of this printed circuit board. See how the bulk of the circuit board has huge copper islands between the LEDs. These are the linking tracks, but because this is almost certainly just a standard printed circuit board material, To dissipate the heat into it, they've got these large islands of copper that will help take the LED from the heat from the LED and dissipate it into the PCB. But the one that has the smallest island of copper, this one down here, has this tiny little island here spreading across, and although that might look reasonably sized over there, it's also the resistors which will be giving off a tiny amount of heat. But the main thing is that what they could have done here that might have prevented this, they could theoretically have extended this island up into here and gone down like that, and that would have increased that by a large area, but they didn't. And that's the LED that's failed. Well, that is the LED at that end that's failed. And what's happened here is that the junction in the LED has failed. It's resulted in sort of that situation where the LED goes open circuit, the voltage across the capacitor in the circuit rises up, and then it arcs over and it sort of makes the contact again, and then but it damages it in the process even further, and then after a while it goes open circuit again, then it pops, the capacitor discharges because the voltage floats up to the full open circuit voltage of the capacitor, which is peak rectified mains, which in this case will be about 350 volts. I should be pointing out there's a capacitor over there. I shall zoom back out again. We don't need to be zoomed in this close. So that has a sort of chain reaction. It just keeps going until finally it pops open circuit, and then that forms a sort of resistive bridge. It looks black inside, and it acts like a resistor, and the LEDs kind of just glow gently around the whole ring. But at that point, most people would take the lamp out and bin it. I'm not going to bin it. What I'm going to do is this. Now, let's take a look at the circuit board here. We've got these big islands. We've got live and neutral coming in. Live is going to one end of the capacitor, which is on the other side of the circuit board. I can guess its position from the circuitry and the sort of outline of it. It goes to the bridge rectifier. The other connection goes straight to the bridge rectifier. It's got the 1 mega ohm resistor across it, the creepily small 1 mega ohm resistor for across 240 volts. That's designed to discharge that capacitor so you don't get a ping. If you were to take this out of a lamp while it was on, this could hold a charge and it could give you a zap, and that's just purely to limit that. Goes through a bridge rectifier. The output has the 100k resistor across it here and the little electrolytic capacitor, and that the 100k resistor is the one that stops it ghosting and also makes sure it goes out decisively. The 200 ohm resistors, I should mention 105, that's 10 and 5 zeros. 104, that's 10 and 4 zeros, 100k, and 101, that's 10 and 10, 100 ohms. And then it just feeds the circuit of LEDs. Very simple circuitry. That is the beauty of these. So here's what I'm going to do. I'm going to bridge out that LED. I'm going to remove it off the circuit board, and I'm just going to bridge it out because I do not have any of these special LEDs. I have standard LEDs. The temptation is to stick a standard LED in, because what I'm going to do is I'm going to replace the capacitor at the back from what I've measured. Let's bring the meter in and show you that. So I shall set this to 2 microfarad because that's typically the range that I'm expecting here. Let me demonstrate this on what I believe to be a 330 nanofarad capacitor. Oh, it's just it's shit tolerance. 315 nanofarad. That'll do. The existing capacitor on the circuit board is, I believe that's, let me see, that's going there, that's going there. I believe it's these two connections here. 463 nanofarad, 464. That hints at being a 470 nanofarad, which is a very standard value. What I'm going to do is I'm going to replace that 470 nanofarad with a 330 nanofarad, which will reduce the intensity of this light very slightly. But it will also extend the life of the LEDs greatly. And it'll also, because the LEDs are running at lower level, they'll be more efficient. So I'm going to pop this circuit board off. Hopefully the cables at the back are not super tight like they often are. If they are, I'll have to improvise and extend them. 99.99999% of people would not do this. That is so tight. That is so annoying. Do you know what they've done here? They've pushed the wires through and they've crimped them in here once they've actually fed them through. That's quite annoying. And then probably just crop them flush at the end. That's annoying. Right, okay. I'm going to desolder those connections. this is going to take a bit longer than expected because of that, but that's okay. Right, one moment, please. Okay, it's getting serious. The cheesy puffs are out, but I've not had any yet. Obviously, if I had cheesy puffs, my fingers would be bright orange by now. That comes later. Orange fingers will be later. Things worthy of note. 25 ohms and a question mark because there's a component down there. I think it might be an inductor. I don't think it's a resistor, unless it could be a 24 ohm resistor. Not really sure. 25 ohms. It seems, yeah, I'm not really sure what that is. I'm not too bothered what that is. The capacitor, and interestingly, the capacitor, they've sat it out, but then they folded the leads down here. It is indeed 3.3 microfarad, which is quite an unusual value. Let's get this capacitor out, which is 470 nano. So let's actually get some fresh, juicy lead-based solder onto that. Oh no, everybody's going to die with the lead-based solder. No, they're not. Jeez. There are so many veteran electronic engineers out there, particularly in telecommunications, who use lead-based solder all the time. It's not like they're actually eating it. Also, with regards to destroying the environment, keep in mind that modern circuit boards have very little solder on them. This still won't get me showered, stop me getting showered by abuse by all the eco-hippies, but not to worry, that is just collateral damage of electronics apparently, because everything electronics is dangerous. We were having a discussion with friends recently about the 5G and the hysteria surrounding it. And a lot of this science that's being put out there is very debatable. They recently had a sort of anti-5G convention, Element, and it was basically showing pictures of babies and kittens and saying, "Do you want them all to be killed?" Well, no, obviously not, but 5G isn't actually going to do that. Let's stick this capacitor in, with dangerous, deadly lead-based solder. Oh no, what about the kittens and the puppies and the babies? And once I've soldered this in, I'm going to sit this back in. Oh, I have to solder the dead LED, solder the dead LED. Let's do that right now. Where is it? It's the one with the black dot. I shall splooge, or splush, some, well, let's just chop that. Let's get some snips onto it and just whack it out. Here it is. Grip it with, yeah, that was quite easy. It's out. Not the best way to take it out because it's still on the circuit board. Right, tell you what, I shall put some solder just all over that. And I shall slide it off. This is where I get solder on the drawing. It doesn't really matter. It's fine. It's well worth just repairing this LED for the pleasure of repairing it. It's quite fun. And a big splooge of solder over that. There, it's splooged. This should be ready to drop in and plug in. So if I can line these leads up and hopefully, having desoldered them, I've just left them where they were. This is where the footriest bit of the whole job is going to be trying to get those leads through the holes. I'll give it a moment. I'll try. Oh, I think I got one of them. I think I got one of them in. If I don't get them in, I shall pause momentarily and then solder them and try it out. I'd rather get them in right now so you can see the test of the LED lamp as soon as I've fixed it, so you don't think there's any jiggity-pokery going on and I've been testing things beforehand. No, I'm going to have to pause. 1 moment, please. Okay, well, it turns out the hardest bit of the job isn't desoldering the components and reverse engineering the circuit. It's actually getting those tiny little wires right back through these holes. But they are through the holes. Look at the mess of all the flux in this circuit board. It's even worse now. This is where Lewis Rossman would probably put it through an ultrasonic cleaner or something like that, but that's not happening here. So let's get this magnet off my snips from recent pendulum type experiments. Let's crop these leads, which I shouldn't have cropped the leads because now they're even shorter. Let's just shove it into a holder gingerly and see what happens. Oh no. Oh, it's lit. Notably reduced intensity. The current has gone down from about, what was that? That was 24 4 milliamps. It's down to 17 milliamps. The rating has gone from 3 watts down to 2 watts. Power factor is slightly worse, but you know what? You'll see a slight shimmer because the capacitor isn't massive for that, and because of frequency interaction with the mains frequency in the camera. Maybe we should experiment with that. But that's it fixed. If I put the cover back on over the front of that and glue it on, that should be it, and it can go back up in the kitchen at this slight hint of reduced brightness, but a greater overall life expectancy. And now it is time for the cheesy puffs. You dirty, dirty cheesy puffs. Oh, you know you like it. My fingers are going to be so orange by the end of this fingering. Oh, yeah.